Our topic for today is exponential function. Before watching this video, please make sure that you watch our inverse function. Just click the link in our card, then it will direct you in that video. And of course, please do not use this as your instructional materials in your online class, because we have different approach here in teaching in secular or in classroom setup. Exponential function. Let us define what is exponential function. Exponential function can be written as function of x is equal to b raised to x. In this case, b will be our base and x is our exponent, where b is greater than 0 and x is any real number. Okay, when we say real number, it can be decimal, fraction, or whole numbers. Since we are dealing with the exponential function, let's have a short recall about the laws of exponent. In this lesson, we will be using two laws of exponent. The first one is the zero exponent. When we say zero exponent, if n is not equal to 0, then n raised to 0 is equal to 1. That means if we have 5 raised to 0, that is equal to 1. 10 raised to 0 is equal to 1. Except for 0 raised to 0, because that will give us undefined. Okay? The second one is the negative exponent. If you have a raised to negative n, that is equal to 1 over a raised to n. Let's say we have 5 raised to negative 1. That is equal to 1 over 5 raised to 1, or simply 1/5. Other example, if we have 3 raised to negative 2, that is equal to 1 over 3 squared. 1 over our negative sign will become positive. And let us simplify, that is 1 over 3 squared, that is 9. Okay. 1 over 9. 3 raised to negative 2 is equal to 1 over 9. Okay? That is our laws of exponent. And now, let's have the characteristics or the properties of exponential function and its graph. It is very important to know the properties and characteristics of exponential function to check whether you are in the wrong process of solving our function. Our first property, we have our condition. Let f of x is equal to b raised to x, wherein b must be greater than 1 and b must not be equal to 1. Our first property is the domain is the set of real numbers. When we say domain, it is the possible values for x. That is our domain. Next, the range is the set of positive real numbers. So range are the possible values for y. So if we're going to examine in our graph and apply our second characteristic, you will notice that the range is the positive or real number. So our graph is on the first and second quadrant, on the upper part of our Cartesian plane. If b is greater than 1, the function is an increasing exponential function. So, increasing, it's going up if b is greater than 1. If b, or the base, is greater than 0, but less than 1, the function is decreasing exponential function, going down. Okay? Then, number 4, the function passes through the point 0, 1. Why? Because if we have f of 0, that is equal to b raised to 0, and b raised to 0, or n raised to 0 is equal to 1. And our last property, or the graph approach but not reach the x-axis. The x-axis is the horizontal asymptote. So it will go closer and closer to x-axis, but it will never touch the x-axis. They will never meet. Okay, to better understand these properties, let's apply using the problem here. Y is equal to 2 raised to x plus 3. We're going to find first our table of values. And of course, after getting the table of values, let us graph. The technique is, we need to apply our laws of exponent. So the given is y is equal to 2 raised to x plus 1. So we have x and y. Technique, let us use the zero exponent. Let us assign the values for x. Then our technique is the exponent must be equal to 0. So apply our zero exponent. So to make our exponent x plus 3 is equal to 0, let us find for x. So if we use addition property, subtract negative 3, that will become negative 3. Or that process is transposition method if you were in junior high school. But if you will study mathematics, there is no transposition in math. So that is the addition property of equality. Take note of that. Okay, so if x is negative 3, let us solve. Y is equal to 2 raised to negative 3 plus 3. This will become 2. Negative 3 plus 3, this will become 0. And 2 raised to 0, that will become 1. So, if x is negative 3, okay, let's write negative 3 here. Our y will become 1. Okay. Next, let us extend one more. Okay. X and y. Since we have negative 3, so on the right side of negative 3, we have negative 2, negative 1, then 0. Then we have negative 4, negative 5. Or we can continue if you want. So negative 3, let us find negative 2. Y is equal to 2 raised to negative 2 plus 3. That will give us, copy the base, 2. Negative 2 plus 3, that is positive 1. 2 raised to 1, that is 2. Okay? Yeah. Okay. So if x is negative 2, our y is 2. If x is negative 2, our y is 2. I will write 2 here. Okay, next. If you want negative 4, negative 1, that's okay. So let's start with negative 1. So y is equal to 2 raised to negative 1 for x plus 3. So this will become 2 raised to negative 1 plus 3, that is positive 2. 2 squared, that is 2 times 2, will give us 4. So if x is negative 2, and negative 1, y is 4. Negative 1, y is 4. And for 0, y is equal to 2 raised to x, let's get 0, plus 3, y is equal to 2, 0 plus 3, that is 3. And now we have 2 cubed. 2 times 2 times 2. 2 times 2 times 2, that is 8. Okay. So 8. And if you have negative 4, y is equal to 2 raised to negative 4 plus 3. So 2, negative 4 plus 3, that is negative 1. Applying our negative exponent, so we have 1 over 2 raised to 1. So that is 1 over 2. 1/2. So if we have x for negative 4, that is 1/2. And last one, if negative 5, I will erase this. So y is equal to 2 raised to negative 5 plus 3. This will give us 2 raised to negative 2. Negative exponent, that is 1 over 2 raised to 2, 1 over 4. Okay. 1/4. 1 over 4. If you notice, to check our fifth property, it will not reach the x-axis. So if we're going to continue negative 6, negative 7, negative 8, the value will be decreasing, but it will never meet our x-axis because that is our horizontal asymptote. So if we're going to graph this, we have 0, negative 8. So 0, then 0, positive 8, 0, then going up 1, 2, 3, 4, 5, 6, 7, 8. This is negative 8, negative 7, negative 6, negative 5, 4, negative 3, negative 2, negative 1. Then negative 1, 4, negative 1, then going up. This is the positive numbers. Positive. Again, let us repeat. Positive 8, 7, 6, 5, 4, 3, 2, and 1. Negative 1, positive 4. Negative 1 going to positive 4. Negative 2 going to positive 2. Negative 3 going to 1. Negative 3, 1. Negative 4, then 1 half, 1 half. Then negative 5, 1 4. Okay. So this is now our graph. Okay. It will approach x-axis, but it will not reach our x-axis. It will just go closer and closer, but they will never meet. So that is our exponential function. And of course, the properties and its graph. Now we have the exponential growth model in terms of compounded or compoundly. We have a new formula. A is equal to P, quantity 1 plus quantity R over N raised to N times T. Okay, wherein A is the compound amount. T is the time in years, in terms of years. In time, we have the semi-annually, you will encounter that, or quarterly. P is our principal amount, and N is the period per year. To better understand our exponential growth model, let's have this example. Pablo invested 75,000 at an annual rate of 6% compounded yearly. Find the total amount in the account after 10 years if no withdrawals and no additional deposits are made. First step, rewrite our formula. So A is equal to P, 1 plus quantity R over N raised to N times the time. Okay, in short, Pablo invested or deposited 75,000 in his bank account with annual rate of 6% compounded yearly. So we're going to find the total amount after 10 years if he does not deposit or if he did not withdraw or deposit in that duration of time. So let us find what is P, the value of P. His principal amount is 75,000. Okay, 75,000 pesos. Next, our rate. Our rate is 6%. In decimal, that is 0.06. Just move 2 decimal to the left. And our N is our period per year. So we're going to find how many years we have. So we have 1 period per year. So that will become 1. And our time is after 10 years. So time is 10. After finding the values for P, R, N, and T, substitute our formula. So we have A is equal to P is 75,000 times 1 plus our R, or the rate, is 0.06 over our N is 1 raised to N is 1 times our time, we have 10 years. Okay. Now we have 75,000 times 1 plus 0.06 divided by 1, that is 0.06, raised to 1 times 10, this will become 10. So 75,000 times 1 plus 0.06, this is 1.06 raised to 10. Okay, let us use the calculator. So we have 75,000 times 1.06 raised to 10. 1.06 raised to 10. This is 1.7908 multiplied to 75,000 times 75,000. So his money will become 134,313.58 after 10 years. Okay, this will be the amount of his money after 10 years, if that is compounded yearly with 6% interest rate. Okay, so this is our problem number 1. We have problem number 2 here. Determine the amount of money if Joe invested 200,000 in the bank with an annual interest rate of 8% compounded. We're going to find letter A, monthly for 10 years. And letter B, semi-annually for 10 years. Okay, for letter A, monthly for 10 years, and for letter B, semi-annually for 10 years. If you want to try A and B, you can pause the video. Then after answering, resume watching to check your answers. Our formula is A is equal to B, 1 plus R over N raised to N D. So let us find our principal amount, that is 200,000. Substitute. Then 1 plus, our rate is 8%. In decimal, that is 0.08. Over our N, so we have monthly. So how many months are there in a year? So our N will become 12. So we have N is 12 times our time is 10 years. Okay. Again, let us repeat. 200,000, that is our principal amount. Copy 1 plus our rate is 8%. In decimal, that is 0.08. Over our N, monthly. So we have 12 months in a year. So we have 12 times, our N is 12 times 10. Simplify. 200,000, 1 plus 0.08 divided by 12. 0.08 divided by 12. This is 0.0067. Okay. You can check your calculator. So this is raised to -3. So we need to move 3 times on the left. That's why we have 0.067. Then 12 times 10, that is 120. Now we have 200,000 times 1 plus 0.0067. This is 1.0067 raised to 120. So 200,000 times, so we're going to raise 1.0067 raised to 120. That is 2.23. So this is 2.23. Now 200,000 times 2.23. So that is, okay, so 1.0067 raised to 120 equals sign, then just multiply it to equal sign, then multiply it to 200,000. And his money will become 445,695.48 after 10 years. 445,695 and 48 centavos after 10 years. If that is the interest rate is monthly. For letter B, semi-annually for 10 years. So we have semi-annually. So A is equal to 200,000 times, I think we don't have enough space. So A is equal to 200,000 times 1 plus our R is the same, 0.08 over our N is semi-annually. Semi means 2. So this will become 2 raised to 2 times our time is 10. So 200,000 times 1 plus divide 0.08 divided by 2. 0.08 divided by 2, that is 0.04. 0.04. 2 times 10, 20. So 200,000 times 1 plus 0.04, this is 1.04 raised to 20. So 1.04 raised to 20, this is 200,000 raised to 20, this is 2.191. Okay, then multiply to our principal amount, 200,000. So 438,224.63 centavos. This will be the amount after 10 years. For semi-annually. An exponential model can be modeled as y is equal to ab raised to x, where a is our starting point, b is our growth factor, and x is the number of intervals. Number of intervals, it can be in minutes, years, days, or weeks, etc. The formula is the same as y is equal to a quantity 1 plus r raised to t, where a is our starting point, 1 plus r is our growth factor. That means r is our rate, our percent, and t is our time or our intervals. To better understand our formula, let us try to solve this problem. If you find out that our channel is beneficial, please don't hesitate to subscribe. Okay? The problem is a bacteria grows at a rate of 25% each day. There are 500 bacteria today. How many bacteria will be A tomorrow, B 1 week from now, C 1 month from now? Let's solve letter A. Tomorrow. There will be how many bacteria tomorrow? Of course, use your calculator. First step, write the formula. Our formula is y is equal to ab raised to x. Next will be identify a, b, and x. So our A is the starting number. So there are 500 bacteria today. So today will be our starting. So there are 500 bacteria. B is our growth factor. Our rate is 25%. 25% in decimal, that is equal to 0.25. Just move the decimal places twice to the left. And our x is our time. So we're looking for the number of bacteria tomorrow. So we're just looking for one day. How many bacteria tomorrow? After finding our A, B, and X, we need to substitute. Y is equal to A is 500, okay, times B. Our given is just the rate. So we need to add 1 in our B. So our B now is 1.25. If you look at our growth factor, 1 plus R. The given is R, the rate. So this will be our B. 1 plus 1.25 raised to 1. Our time. So 500 times 1.25 raised to 1 is 1.25. So let us use our calculator to solve. So 500 times 1.25. There are 625 bacteria tomorrow. There are 625 bacteria tomorrow. If you want to try B and C, pause the video, then answer B and C. Then after answering, resume watching to check your answers. Letter B. So 1 week from now. So identify A, B, and X. So our A starting is 500. Our B, same, 1.25. And our C, no, our X. Our X is 1 week from now. So how many days in a week? There are 7. So we will use 7. So Y is equal to AB raised to X. So A is 500 times our B is 1.25. Then our X is 7. So 500 times 1.25 raised to 7. If you want to find the raise symbol, use the symbol. Raised to 7. That is 4.77. Then times 500. Just multiply to 500 times 500. This will become 2,384.19. And that is estimated answer is 2,384. Because we are looking for bacterias. Number of bacterias. So it must be this or in this case. Next, letter C. Okay, our A is 500. Our B is 1.25. And our X is 1 month from now. So how many days in a month? There are 30. So our X is 30. So Y is equal to AB raised to X. Substitute. So A is 500 times B is 1.25 raised to 30. So 500 times 1.25 raised to 30. That is 807.79. 807.79. Then just multiply to 500. That is 403,896.78, or the estimated value is 896. Since we are looking for the number of bacteria, this will be the final answer. No decimal places. Okay. So that's it. That's the mathematical model for exponential function. So just use the formula. Focus on our growth factor. This is confusing. Just don't forget to add 1 in our B. Okay, because the given is the rate. Once again, thank you for watching Señor Pablo TV.